Does Docker Compose still make sense in 2025? And if so, does it have any potential to stay relevant? I'm a strong believer that many software projects do not need Kubernetes or a complex cloud setup. For each Netflix with swarms of microservices, there are hundreds of thousands of smaller shops. There you will often have a classical three-tier architecture. Your deployment target would be an on-prem server, an industrial computer, or even a $5 VM. But if your project is small, does it mean you need to give up all the benefits of containers and the time-proven DevOps practices? No, of course not. Is there a reliable and simple tool for that? Let's see. Yes, it's 2025, and I will try to build an end-to-end solution for development, deployment, and maintenance of a small web application. And this solution will be based on Docker Compose. Here are my guiding principles for this enterprise. First, the development environment should be as close to production as possible. And here I'm not only talking about the reproducibility of separate application artifacts, but of the whole stack in its entirety. Second, security practices, or I would say safety measures, really, should start from the very beginning of the conveyor belt, that is, from the development environment. And finally, the third principle. The solution itself should be as resource effective as possible. To prove the point, I will deploy it to one of the cheapest DigitalOcean VMs. In the end, I will try to build a containers-based stack with simple and effective secrets management, automatic TLS certificates management, zero-downtime deployments, and a lot of fun. No operators for operators, no layers upon layers of overlay networks, no Golang templates. If you know, you know. And yes, just one single YAML file, trust me. Everything I will show here is available on my GitHub. You can absolutely reproduce what I'm doing here for your project. If you like, you can put the whole workflow on CI/CD Rails with minimal effort. I will start slowly for those of you who never used Docker Compose before, and then we'll go on with more and more advanced stuff. So, welcome, and I hope you enjoy the journey as much as I enjoyed working on it.
Let's go to work.
As I usually do on my channel, a little bit of history to explain the trajectory of the today's hero, where it comes from and where it's probably going. In December 2013, just half a year after the world got to know that containers can be usable, a new tool written in Python promised lightweight development environments using Docker. The new tool was called, no, not Docker Compose, it was called Fig. Here's its original README file. It uses simple YAML configuration file. 12 years ago, this didn't sound suspicious. Anyway, Fig allowed you to start a bunch of containers together and manage them as a group. It did that by talking to Docker daemon via its HTTP API. More than a year later, the project reached version 1.1.0 and finally got the name we all now know. Since then, Docker Compose configuration format changed, but it was still a Python tool clearly separated from the Docker itself. That is, until 2020, when Docker Compose was rewritten from scratch to Go language and became a Docker plugin, which on the surface just meant you could not only call it Docker-Compose, but also Docker space Compose, like a serious person. But in fact, Compose v2 became faster, Compose configuration format was finally stabilized and published as a spec for other companies to adopt. Suddenly you could deploy your Docker Compose stack to AWS almost without any changes to your Compose YAML file. But today there will be no big clouds with pages and pages of services and complex billing models for which you need to hire someone to make even sense of it. No, no, no. I've ordered a simple $6 a month Debian VM on DigitalOcean. What else do I need? Not much. A DNS zone. In the registrar's web interface, I've pointed my domain to DigitalOcean's named servers. And a subdomain in that zone is now pointing at my new VM's IP address. Finally, I need an SSH key. Ah, good old SSH. Time to start working on my little artificial intelligence application that will turn any phrase into a part of Donald Trump's speech.
How do you like my garbage truck?
It's just the two components, a Python application that calls the OpenAI API and a PostgreSQL database which is used as a permanent cache to try to save some tokens. Good people, if you want to get experience building something bigger than a toy web application I'm playing with today, give CodeCrafters a try. It's a practice-oriented learning platform which works like this. You choose a programming language, for example Python, and then start a project. Let's say you pick this one, build your own HTTP server. Here you work in stages, moving from an empty Git repository to a complete project. For each stage, you get an instruction, start working on the code in your editor of choice, push your changes, and if automated tests pass, go to the next stage. This is a much better way to improve programming skills than just reading a book, because saving knowledge for the future just doesn't work really. But if you reach out to a book when trying to solve a practical challenge, then the puzzle pieces fit together and stay together. This is how you build a skill. Click on my referral link in the description below and start working out your programming skills with CodeCrafters. By following my link, you will also support my work on this channel. Thank you very much, and let's continue with Docker Compose. Okay, so Docker daemon is running, Compose is installed. I'm in my project directory. Now I need the actual Compose file. There is no Docker Compose init command that can generate a scaffold of a config to start working with, but the structure of a Compose file is quite simple really, so I will create it from scratch right now. There are only 5 top-level keys here: services, networks, volumes, secrets, and configs. Obviously, the most important and the only required section is services. This is where I will put my container definitions. As you can see, there are 2 ways Docker Compose can start my containers. Either by pulling an image from a registry or by building an image right here from a Docker file. This is typical Docker file for a Python web application. Notice I've put an expose statement here and defined a command to run when a container will start from this image. Okay, this 5 lines config file is already valid, and Docker Compose will downright try to run my stack. But unfortunately, the Python application just won't yet boot up. This is because it expects an environment variable. Of course, I could do something like but I said in the beginning, safety measures. So let me show you how Docker Compose secrets function. There is a dedicated top-level section secrets. Here I can define how my secrets enter Docker Compose perimeter. They can either be sourced from files or from environment variables. Security-wise, there is not a big difference between the 2 options, but in my opinion, file-based secrets are easier to manage and harder to accidentally screw up. This is what I will do. I will create a directory called secrets. This directory should never be managed by Git. Okay, so here I prepared 2 plain text files, one with a PostgreSQL master password and one with the OpenAI API token. I believe secrets, being a part of configuration, should be versioned in Git, but of course not in plain text. So I will now install a nice little tool called H. I like H because it can reuse my SSH keys for file encryption. Of course, for the demo I will create a new SSH key pair. Okay, let me create another directory. This time it will be added to Git as usual. Now with Git history, I will be able to check when exactly a certain secret has changed. The only unfortunate thing about H is that it doesn't work with an SSH agent, which means that if your SSH key is passphrase protected, there will be no way to script secrets decryption with H. So when you will change a secret at some point, you will have to call H before your application deployment and enter the SSH key passphrase in a terminal. Or maybe you would have to use the forgotten magic. So now I have my secrets encrypted in Git and in plain text in git ignored directory. Here's where I will make Docker Compose look for them. This is how I declare my secrets in Docker Compose world. And here's how I'm allowing my containers to use the secrets each of them needs. What will happen after that is Docker Compose will mount my secret files to /run/secrets directory in those containers where I allowed particular secrets. Now obviously PostgreSQL server by itself has no idea about Docker Compose and its secrets, but the official PostgreSQL Docker image supports reading credentials from files. I just need to point it to a right path with an environment variable. By the way, official MySQL and Grafana Docker images also work this way. For my Python application, I've added support for reading secrets from files by myself. Nothing spectacular. Okay, a couple more things really, and my development environment is completely ready to roll. Let me add a volume to the DB container so that my data is preserved after the container restarts. Without a volume, PostgreSQL container will start from a blank state every time.
What am I doing here?
Not what I want for sure. I would also need to mount my application source code to the Python container because I don't like the idea of rebuilding the container on every code change while I am developing. This will be a different volume type, a bind mount. Now, the code changes on my host system are immediately available in the container. And finally, I need my Super AI web application to be reachable in a browser. If I wanted to access someone else's container and I wouldn't know which ports it listens to, let's say I want to access PostgreSQL from my host system, and let's say I forgot the default PostgreSQL port, the way to go is docker inspect. Expose is just a declaration or a useful hint, nothing more. Being a good person, I've put an expose statement in my own Docker file. But now, to actually publish port 8000, I need to add a couple of lines in my compose file. To memorize what these two numbers mean, think about the direction of incoming traffic to a published port. Incoming traffic will always first reach the port on the host system and then in the container. So the second number is what is usually declared in expose, but first number can be whatever you want. Now, good people, I present you the pinnacle of my front-end skills. Thank God there is Tailwind, and thank God there's Alpine.js. Otherwise, I'm not sure if I would be able to do anything at all. Anyway, it works, and it's good enough for the demo. Database records are saved, all good. I can edit code and my changes are immediately visible. Okay, ready to ship to production? Not really. There are still some things to check on my safety list. What I don't like right now is that my application container runs as root. I will create a new group and a user in the container with user and group IDs, matching those of my host system user. Now it feels much better. Just to be sure I haven't overlooked anything important, let me also run a couple of linters. One for Docker files and another for container vulnerabilities. Just for a case. I've prepared a just file with the right commands. If you don't know yet, just is a command orchestrator like make, but without quirky behavior designed for compilation. By the way, I have a video that shows how to use just and 3 other command line tools to manage software projects. Quite a bunch of critical issues with the Gosu tool. Not sure what it's doing in my database container though. What can I do about it? Oh, and Heidelint is not happy with my Docker file. So it says that Debian packages have to be pinned. Totally makes sense. I use Poetry to pin my Python dependencies, so let me do the same for system stuff. Of course, there is a tool for that. Nice. Okay, safety measures seem to be addressed, at least those I could do something about now. The first principle I've taken before starting this project is to set up the development environment as close to production as possible. So let me add an HTTP proxy to the stack. Because the proxy is absolutely required in production, it's a critical part of the zero-downtime deployment workflow. For now, the proxy will serve requests with a self-signed certificate, but in production it will use a proper Letsencrypt one. Now that both my application container and the proxy are in the same ingress network, the database container is not reachable anymore because it is still in the default network. But that's very easy to fix. Now, what about scaling my app? Is it becoming more resilient? As you can see, Docker Compose started 3 copies of my application container, but if some or all of them die, Docker Compose doesn't do anything. But it shouldn't be like that. Now, if the PID1, the main process of a container, dies, Docker Compose will immediately spawn a replacement. There are several different modes of restart. For the dev environment, I always use unless stopped. It means if containers were stopped by whatever means, don't do anything. By the way, Docker kill is considered stopping a container. For production though, I will use restart always. It still won't try to revive a container that was killed, but if I would have to reboot my cloud VM, Docker Compose will bring up the stack back online automatically. Okay, so now if my UVcorn process would die, Docker Compose will bring up a new container.
Very nice.
But in reality, it's easily possible that the main process is running, but the application itself is not doing what it's supposed to do. To know that my application is not ready for work, I will use a health check. In my fast API code, I've added /health endpoint that tries to execute a dummy SQL query on the database. This allows me to check if the dependency of my application is reachable and can process queries. With this change, Docker now reports if my application's health check is failing. But this is where Docker's responsibility ends. By itself, it can't do anything with this information. To make health check reporting actionable, I need another container. Interesting to note, this container has network mode set to none, which means that Docker Compose won't attach network interface to it. And that's fine, because all that the unhealth container needs to work is the access to the Docker Server API, and it uses a Unix socket for that. At last, my application's health check is useful. Time to prepare my little cloud VM. Let me install all the required software and set up a user account that will be used to run the stack. By default, when you update a Docker Compose service, it first stops the old container and then starts a new one. Docker Compose by itself has absolutely no built-in mechanism for zero-downtime deployments. But if you think about it, what has to be done is not that complicated. Why don't we just leave the old container running all the way until the new container is fully ready for work? This is exactly what the last missing piece of my Docker Compose setup does. Kedic functions as a Docker plugin, just like Docker Compose itself. It orchestrates deployments in such a way so that I have a seamless junction between an old and new versions of my service. Now, to summarize differences between my dev and production setup. In production, I don't need UV-Corn to watch for application source files changes. It also makes no sense to mount source code into application container. For production, I expect Caddy to request a valid Letsencrypt certificate for the domain name that I've pointed to my cloud VM. I also have a separate health check configuration to be used by proxy so that during deployments, it's not sending traffic to a new container which is not fully ready. And of course, for all containers, the restart policy is set to always, to guarantee that my stack is started after a VM reboot. This is how a deployment looks like. As I said in the beginning, it's fairly easy to automate this process with a CI/CD pipeline. It's just the 3 steps. Git pull source code updates, decrypt secrets, and run docker deploy command. If you can use a Docker images registry, that's even better. Just add step 0 to the pipeline to build and push an updated Docker image for your application. If you followed me from the beginning of the video, you have seen that I implemented an easy-to-maintain secrets management workflow, simple scaling and service resilience based on containers health checks, fully automated TLS certificates management, and finally, zero-downtime deployments. All of that works on top of Docker Compose. All of that with production and development environments as close to each other as possible. With some more extra work, you can extend my setup with database volume backups. Very easy to configure and light on resources server monitoring with net data, and much more. All the links to the tools I recommend are on the Art of the Terminal's GitHub. So what are my conclusions? Docker Compose is in fact just a thin layer on top of Docker itself. It adds no new abstractions, which means if you know and use Docker, getting around with Docker Compose will not be a problem. But even without new abstractions, it adds a lot of value. Of course, it's not an orchestrator for distributed applications like Kubernetes, but it never pretends to be anything like that. I also don't think Docker Compose will introduce any new groundbreaking features, which is actually a good thing. The Compose configuration format has been very stable since version 2, and I believe it will remain so. And Docker Compose is so straightforward that there is almost nothing to learn. You can just start using it when you need it. All in all, it is a tool you can totally rely on if you want a simple and easy to understand container-based stack where, with help of additional tools, all the proven DevOps practices can be covered. Thank you for watching, and see you next time on The Art of the Terminal.